Hello, hello. Time for some algebra. I hope you all don't like this method too much because I'm coming back tomorrow. So today our goal is to be able to solve logarithmic equations. So if you remember log base 3 of x, looking at that thing, the logarithm is the function. 3 is my base. And x is known as the argument. And no, stop arguing. It's not very kind. Now, if the logs are the same, so I have the same base and the logs on both sides of the equation, then you can set the arguments equal to each other and solve for the variable. So in this scenario, it is the easiest way. Like I said, we're going to start out easy and then work our way up. And then you always, how often? Always want to check your solutions and the original equation, because you cannot have a negative value. In logarithms. So just a little reminder from our graph of logs, it looks something like this, where it's like, woohoo, and we had that vertical asymptote, we had the va, and the domain was x had to be bigger than 0. So and even if you plug it in your calculator, log, and you type in a negative number, it'll say error, it doesn't work, it has to be bigger than 0. You can not have a negative argument. Now, an extraneous, yes, those are back, solution is an answer you get that is not in the domain of the original problem. So we will have to do a quick little checky check when we get our solutions just to make sure if it is extraneous or not. So these first couple examples, and for this one I want you to change that to a 4x, pretty please. Thank you. They are, you notice, I have log and the base on both sides of the equal sign. So remember, what you do to one side of the equation, I can do to the other. So since log is on both sides, I can simply just ignore it on both sides. And yes, this is legal math. And I get x equals 3. And then if I check, hey, I would have a 3 right here. And that is a-okay because it's on the other side. Happy days. Next one, I have ln of x plus 2 and a 4x. Since ln is on both sides, I can ignore it on both sides, and I get x plus 2 equals 4x, and now I just solve for my variable. Subtract x. I don't know why there's a box around that. And I get 2 equals 3x, divide by 2, or 3. Just making sure you're paying attention. And I get x equals 2/3. Again, we check. If I plug this in here, or if I plug this in here, that just gives me positive answers. So easy's good. Yay! Next one. Yay, fun with factoring. I know you're all excited. So the log 5s cancel out, and I'm left with x squared equals 5x minus 6. What do I do now? I'm going to move everything over. So it's equal to 0. Now, I don't know what that just did, but anyway, I'm going to solve it myself. Now, if you love, like me, and you love factoring, I'm going to factor away. If you want to do the harder way like Mariah sometimes likes to do, then quadratic formula. There you go. Whatever floats your boat, factor, quadratic formula. But remember, I'm trying to figure out what multiplies to get my last term and adds to get to my middle. So remember, it's ax squared plus bx plus c. C is the last term, b is the middle term. So my last term is a positive 6. My middle term is a negative 5. Factors of 6 are 3 times 2. Oh, that gives me positive 5, but not negative 5. Remember, flip them both. Negative times a negative gives me a positive, also gives me a negative 5. So my factors are x minus 2, x minus 3 equals 0. Then take both my factors, set them equal to 0. And I get x equals positive 2, x equals positive 3. And now we check. If I plug 2 and 3 into the first term, That would give me a positive 4 and a 9, so that's good. The second one, 10 minus 6, that's good. 15 minus, so they're both good. And we will see ones where it's not good, so don't worry. It's coming. Oh, biscuits. I didn't mean to make that little mark. Anyways, all right. Here would be a good time to try yourself, so pause the video or just keep following along. We can ignore these x log 4s because they are the same on both sides, so I'm just working with the argument. So I have 2x equal, whoa, what was that? 3x plus 5. Solve it. I'm going to get negative x equals 5 because I subtracted the 3x over. Stop doing that. And that's it. Oh, wait, no, it's not it. Huh? Negative 1 divided by negative 1. And I get x equals a negative 5. Stop. Mr. Hooker's thing is haunted. All right. Did I do that right? Yep. All right. Now we check. If I plug negative 5 into here. 2 times 5. That's negative 10. Oh, biscuits and gravy, buttons and bows. What do we do now? Extraneous. There is no solution. Oh, all that work for nothing. So sad. All right. Now, for these next part, we have to do a little more work. But we are up to the challenge. Yes, we are. Now, this says use the log properties to solve and then check for the extraneous solutions. So in this scenario, I still have log on both sides. So happy days, there's just a little extra work. What we need to do is we need to condense first. And that's the properties that you learned, hopefully, on Friday, I believe. Condense first. So remember the key things. Adding and multiplication go together, subtraction and division go together. So when I see log 3x minus 4 log squared, or 2, log base 3, 2 equals log base 3, 4, I'm like, ooh, I see some exponents. So this will be log base 3 of x. Oh, what goes with subtraction? Division. And that would be 2 to the 4th equals log base 3, 4. And then I'm like, oh, happy days. The logs, bye-bye. And I have x over 2 to the 4th is 16 equals 4. Now to solve for x, I get x equals 16 times 4 is 64. And if you check, oh, that is A-okay. No problem with you. Sorry, I'm trying to zoom in, but also not erase it because I know some of us are a little slower sometimes, and that's okay. Snow loves. All right, here, what goes with addition? And hopefully everybody says multiplication. Yay! So I have log of x plus 4 times x plus 6. Yeah, I get to do some double distribution. Log base 3. So I distribute this. Wee-hoo! And aha, I can say bye logs because they're on the same side. They're both on the equals side. And so I'm going to get x squared plus 6 plus 4. I'm going to get plus 10x plus 24 equals 3. Subtract over the 3. I get x squared plus 10x plus 21 equals 0. So going back to my factor chart, what goes into 21 and adds up to 10? Oh, well, that is just 7 and tree. And then I said, okay, well, that is x equals negative 7. Your factors are always opposite of your solutions. And then I say, oh, I must check. I have to watch out for the extraneous. Extraneous. If you plug negative 7 into either one, oh no, biscuits and gravy, that will give you negative. She's extraneous. But what about negative 3? Oh, she's just fine and dandy. So this and this alone is my only solution. And if you forget to check, yes, you will lose points, and I cry. All right. For this one, try and keep it so you can still see the little one. Woo. Again, we want to condense first. And look, this time I have something to do over here. Woo! You belong back there. And then what goes with plus? Oh, that's a multiplication. So this is going to condense into log 4x squared equals log negative 4 times x plus 1. Yep-be-doo. Can cancel out the logs, and I get x squared equals negative 4x minus 4. Put everything to the x squared side. Okay, what factors to get 4 and adds to get 4? Well, hot diggity dog, that's just 2 and 2. So I get x equals negative 2 as an answer. Then I want to check. Always want to check. Oh, no. If I plug it in here, or if I plug it in here, I get a negative value for my log. Uh-oh. Not only is it extraneous, there's just no solution, period. Oh, poor thing you. And again, if this is ever going too fast, please pause me. Now, where did the other one go? Oh, here she is. Okay, flip over your page. We got some more learning to do. I believe you all can do it because you are smart. Okay. It says we can solve logarithmic equations. Remember that exponential and logarithmic functions are inverses. Oh, I just should have said inverse. Inverse functions. There we go. And inverses have the ability to undo each other. This ability to undo means that we have a logarithmic equation. We can apply the exponent of the same basis at the exponents equal to each other, or convert the log to exponential and solve. So right here is kind of my little how-to. And notice, you see this word, isolate. You always want to isolate the log term on one side of the equal sign. And sometimes you need to do some combination, some condensing. And then we want to write the equation in exponential form, or what I like to do is I call it, I'm going to exponentiate. Doesn't that sound fun? That's a new fun verb. Exponentiate. And then solve for the variable. So notice, now if you look at these equations, there is not log on both sides. That function is not appearing on both sides of the equal sign. So I can't just simply say, bye-bye. I have to get rid of it by exponentiating it. So, for this first one, I have nothing being added or subtracted, so I'm just going to go ahead and exponentiate. So you're always going to match the base. The bases should always match. So I'm going to write this out long ways, but usually I will just write this. I will go 7, 7, and I will exponentiate it. And let's change this number 17 to a 2 to make our lives a lot easier. But what I am doing by doing this, I am saying this is 7 raised to the exponent of log base 7, x minus 3, equals 7 squared. So that, you do not have to write this each time, but that is what I'm doing. Because these match exactly, woohoo, that base and that base. They cancel each other out because they're inverses. It's a beautiful thing. Math is beautiful. And I'm left with x minus 3 equals 7 squared is 49. And then I just solve. Hot diggity dog. And I get x equals 46. Check. Will that make me extraneous? Nope, she's groovy. And that's my answer. All right, on number 2, it says I have 10 plus ln of x plus 3 equals 14. Don't forget, isolate. I want this, the log part, all by itself. So I need to get rid of that 10 first. So subtract the 10 over, and I have ln x plus 3 equals 4. And now we just have to remember, what is the opposite of ln? Well, if ln is the natural log, what is the natural exponent? And hopefully we can remember, since last week, the natural exponent is e. E. Remember the dolphins? So the E and the ln, they cancel each other out. Bye-bye. And I'm left with x plus 3 equals e to the 4th. Now, you can actually leave the problem as e to the 4th, or you can use your calculator and plug in e to the 4th. It equals something, but I don't know off the top of my head. And I'm just going to leave it as e to the 4th minus 3. And call it a day. All right. For number 3, there's nothing to isolate, so I can go ahead and exponentiate. I have to match the base. The base is 4, so the base for the exponent will be 4. So I'm exponentiating all this. So this will cancel out. I'll have 3x minus 2 equals 4 squared. 3x minus 2 equals 16, and then solve. 3x equals 18, x equals 6. Is that fine and hunky-dory? If I plug 6 back in here, yes, that will give me a positive answer. All right, almost finished. It says use the logarithmic properties first to simplify to 1 log. So we are, again, condensing first, and then we're going to solve. So already I'm going to tell you we're not going to do this one, so there you go. For this one, I want to condense first what goes with, okay, and remember, our properties of exponents, adding and multiplying, subtracting, and division. So this is going to rewrite as log base 4 of 3 times x. If you don't want to write x times 3, that's fine. I just like the 3 font. 2. Whoa. Okay. There's not log on both sides, so I can't just ignore it. I'm going to exponentiate. So I get 3x equals 4 squared, 3x equals 16, x equals 16 thirds. And if I check that answer, I can plug it in right here. Happy days, that is fine. For this one, don't forget the numbers out front are your powers. I got the power. So this is going to be log base 4 of 2 to the 3rd with addition is multiplication. X squared equals 2. I'm going to exponentiate. The base is 4, so the base has to be 4. This is going to cancel out. I'm going to left with 2 cubed is 8. X squared equals 16. Solve for x. I'm going to divide by 8. Get x squared equals 2. How do I get rid of the square? Take the square root. And when we do the square root, don't ever forget the, hopefully we're all shouting, plus or minus. So I have radical 2. And then I have x equals negative radical 2. Are they both okay? Bum-ba-da-bum. If I plug in a negative biscuits and gravy. Extraneous. So this is my only answer. Okay. For this next one, again, I would see if you can get these answers yourself. You should get, I'm just going to write them quickly, x equals 9, x equals 40. And for this one, you get x equals 12 and x equals negative 3. But this one right here is extraneous, so it's just that one. And I will see your beautiful faces tomorrow, Lord willing.